We want to use a given zero to write a polynomial as the product of linear factors. Now, the linear factor theorem tells us that if a is a zero, or c is a zero, or some number is a zero of a polynomial, then x minus that number is a factor of the polynomial. So if f of c is equal to 0, then x minus c is a factor of f of c. So I'm given a polynomial and I'm told that 1 is a zero of multiplicity 2. I'm going to use synthetic division to divide out an x minus 1 and another x minus 1. So 1 is a 0. So 1, 1, -7, -7, 40, 40, -34, -34, remainder of 0. Excellent. Now remember that this row now represents the coefficients of a third degree polynomial, whereas I started out with a fourth degree polynomial. And I know that 1 has a multiplicity of 2, so I'm going to take out another one. And again, a remainder of 0. Now I have the coefficients of a quadratic expression, x squared minus 6x plus 34. And I could stare at that and try to factor it, but I'm told that I have complex zeros, so I might as well just go ahead and use the quadratic formula. The quadratic formula says that x is equal to 6 plus or minus the square root of 36 minus 4 times 1 times 34 all over 2. And this is 6 plus or minus 36 minus 136, so that's negative 100 all over 2. And that is 3 plus or minus 5i, right? 6 divided by 2 is 3, and 10i divided by 2 is 5i. Now, I need to express the original polynomial as the product of linear factors, and here's what this means. I know that I have an x minus 1 because 1 is a 0, and I know that that has multiplicity 2. And then I know that I must have x minus each of these. So minus 3 minus 5i and x minus 3 plus 5i. Okay? Be sure that the sign change happens between the real and the imaginary part of the root. This can also be written as x plus 1 times x plus 1 times x minus 3 minus 5i, x minus 3 plus 5i.